So I hope you know this position vector. So now AB or AO is negative of OA because we're changing the direction. So we'll write the negative, we'll change sign, that is 1, minus 1 will be 1, 3 will be minus 3, and minus 4 will be 4. Plus OB will write as it is. This is 2 minus 3, 5. Now add them. This will become 2 plus 1, 3, minus 3 minus 3 minus 6, 4 plus 5, 9. This is AB. Now BC. For BC, we will go like BO plus OC. So BO is the opposite of OB. It will be minus 2, 3 and minus 5. Change the sign of OB. And OC as it is 4 minus 2, 5. So by adding minus 2, 4, which is 2, 3 minus 2, 1, 5 minus 5, 0. This is our BC. So take the dot product AB dot BC. If it is 0, then they are perpendicular because cos 90 is always 0. So you know the dot product is the magnitude of this into cos theta. So if it is 0, it means cos is 90, and cos 90 means they are perpendicular. So 3 minus 6, 9, 2, 1, 0, which is 6, minus 6 minus 0, which is 0. Therefore AB is perpendicular to BC. This is proved. Now show that ABCD is a trapezium. For trapezium we need two things, that two sides are parallel and this is perpendicular. So we already proved that this is perpendicular to this. We need to prove AB and CD are parallel only. So how can we prove this? We need DC first. For DC we'll go DO plus OC. For DO I will use opposite of OD. I'll change the sign, and for OC I'll use as it is. So DO will be minus 2, 1, and OC will be 4, minus 2, 5. So this will be, by adding, this will be 2 minus 4, 6. Okay. So I can write it as DC is, take 2 common, it will be 1 minus 2, 3. Now DC, if I multiply by 3 here, I will divide by 3 outside, so that I can divide and multiply by 3. So why I am doing this, I'll explain you in the next step. So I'll multiply inside with 3. This will become 3 1s are 3, 3 2s are minus 2s are 3 minus 6, and 3 3s are 9. So if you see, this is the value of AB. So I can write it as AB here. So DC is equal to 2 by 3 AB. So you know, by the definition, if a vector is a constant multiple of another vector, then they both are parallel. So the K is here 2 by 3. So these two vectors satisfy this condition. Therefore AB is parallel to DC. So this is proved. Therefore A, B, C, D is a trapezium. This is answer. Next is the third part. Find the area of the trapezium. And I hope everyone knows area of trapezium is 1/2 into sum of parallel sides into height. So we know the sum of parallel sides. We know the parallel sides 1/2, which is AB and CD. So sides length, will use the lengths here. Actually we'll use the magnitude of vectors. So two parallel sides are AB and CD. In the previous part we proved. So we'll use magnitudes here. AB magnitude plus BC magnitude, DC magnitude into height. Height was this. I can explain you from the picture. These two sides are parallel and this is height, BC. So I'll use BC magnitude here. Therefore 1/2 AB magnitude is 3 square plus minus 6 square plus 9 square square root plus DC magnitude is 2 square plus minus 4 square plus 6 square into BC magnitude is 2 square plus 1 square plus 0 square. I hope you know how to find the magnitude of the vector. So 1/2, this will become 9 plus 36 plus 81. This will become 4 plus 16 plus 36 into 4 plus 1. So this will be 1/2. This is 126 plus this is 56 into under root 5. So this will be 1/2 into, by adding all these two by the calculator, you will get 5 under root 14 into 5 under root. And by solving all this, you will get 20.916, which is 20.92 area. This is our answer. So that is the question number 10. Now the question number 11 is the diagram shows a shaded region bounded by the curve and the y line -1 and the curve this, which is x minus greater than minus. Express this in the form this. Hence for this represent x in terms of y. So okay, this is completing square form. So I have y is equal to x square plus 4x plus 3. So y is equal to, I'll separate these two. This is the procedure of completing square. I'll try to complete the square of this part. Y is equal to x square plus 4x. I need to add and subtract the square of the half of the coefficient of x. So coefficient of x is 4, its half is 2. So 2 square, add and subtract. 2 square plus 2 square minus plus 3. So y is x square plus 4x plus 4 minus 4 plus 3. Now y is equal to x square plus 4x plus 4 minus 4 plus 3. So if you look closely, it is x plus 2 whole square minus 1. So I can write it as y is equal to x plus 2 whole square plus into minus 1. This is my required form. If you see x plus a square plus b, this is x plus 2 plus b. This is part 1. Second part is hence showing all necessary working, find the volume obtained when shaded region is rotated 360 about the y-axis. So we need to rotate this shaded region about y-axis. So we need these boundaries minus 1 and 3. You need to keep in mind these. The area will rotate about the y-axis. So this y-axis area rotation, when area rotated, the volume of revolution formula is volume of revolution about y-axis is pi x square dy, volume minus 1 till 3. These are the limits. So for this I need x square first. I need x actually, and I'll go back to part 1 from here. Yes, actually I didn't complete this. Express x in terms of y. So I will make x subject here, so I'll take 1 on this side. Y plus 1 is equal to x plus 2 whole square. I can write it as x plus 2 whole square is equal to y plus 1. Take square root of both sides. So it will be x plus 2 is equal to y plus 1, or x is equal to y plus 1 square root minus 2. This is the expression I'll use next, but I'll use x square. So it will be pi minus 1 3 x square. I'll use the square of x, which is y plus 1 minus 2 whole square dy. Okay, so pi minus 1 3, I'll open the square root. This square means y plus 1 minus plus 4 a square plus b square. I can write it as this one for your convenience. Yeah, this is pi minus 1 3. It will be y plus 1 plus 4 minus 4 under root y plus 1 dy. So this can be written as pi. So I can use the next page because this is the last part, so there will be available. Yes, minus 1 3. So it will be y plus 5 minus 4 y plus 1 1 by 2 dy. So I'll split up here the whole into small, or I can go directly y's integration is y square over 2, 5's integration is 5y, and minus 4 y plus 1 1 by 2 plus 1 over 1 by 2 plus 1 minus 1 3. So pi y square over 2 plus 5y, and this can be written as 3 by 2 minus 4 y plus 1 3 by 2 over 3 by 2 minus 1 3. So pi y square over 2 plus 5y minus 2 will go up 8 over 3 y plus 1 power 3 by 2 minus 1 3. Now I will apply these limits. So this will become pi 3 square over 2 plus 5 into 3 minus 8 over 3 into 3 plus 1 power 3 by 2 minus this one minus 1 square over 2 plus 5 into minus 1 minus 8 over 3 into minus 1 plus 1 power 3 by 2, this one. So it can be written as 9 over 2 plus 15 minus 8 over 3 into 4 power 3 over 2 minus 1 over 2 minus 5, because this will become 0. So after simplifying, it will become pi 9 over 2 minus 64 over 3 plus 15 minus 1 by 2 plus 5, which will be 8 pi by 3 or 8.38. This is our answer. So that's it, the end of the paper. So this is the complete solution of 9709 paper 11 October November 2019. So this is the end of the video. If you like, please like and subscribe to my video for the updated videos. Thank you very much.